Assalamu alaikum students, your instructor Abdul Rafi here. So today we have got an yearly past paper solving session and I'm doing Cambridge A Level Mathematics, Statistics 2, S2, Paper 6 and Variant 2. Some important instructions that yearly past papers helps when you have done topicals and you know all the concepts. So since we have covered all the concepts for the statistics 2, it is time to do yearly past papers as well. I'm doing one of the most recent paper solving, which is October, November 25. And we have got paper 6 variant 2 with some basic instructions. As everyone knows, you have got 1 hour 15 minutes to solve the statistics S2 paper, and it is worth 50 marks of the total 50 marks. The total marks for the paper are always 50. Okay, so what we need to understand for this paper, we have got almost 6 questions, students. Okay, so the examiner have asked 6 questions, which means that all of the topics are tested as always. So we have got 6 questions. The one of the important things before starting this yearly past paper, students, for the probability and statistics is about the grade threshold. So I would like to make sure that students have an understanding that in this paper, which is of the October, November 25, paper 6, variant 2. So if the students need to get 36 above, 36 or more than 36 out of the 50 marks to get an A grade in the statistics 2 component S2 paper 62. And if you look at the other components, like other variants, if you look at other variants 61, 63 and 65, so it's very high threshold, which means that this 46, 46 and 44, all three respectively, students, is high threshold. But the paper that we are doing have 36 marks. You need to score 36 or more than 36. That's the grade threshold or grade boundaries, which means that this paper is difficult and we are doing one of the difficult papers or a hard paper, hard difficulty level paper. And we need to score more than 36 out of 50 or 36 to get the grade. Make sure you have calculators, you know the basic concepts, the formulas. So let's get started with question number 1, which is I've already written down the topic. It is on the Poisson distribution. Okay. So question number 1 of the October, November 2025 Cambridge A Level Maths is students on the Poisson distribution. So let's get started. So question number 1 says that the examiner wants you to understand that we have got the number X, which is of used computers donated to a charity by have a constant average of 2.5 computers per week. So we have got the mean or the Poisson mean that we call it is 2.4 computers per week that we have got of used computers to a charity. You have to state a necessary condition. So a conceptual question at the start for part A, you have to state a necessary condition for X to have a Poisson distribution. So what will be the condition? Make sure to get that 1 mark, you should use the word of computers, that computers are donated. That should be independent, or you can say that should be single event or randomly. The computers that are donated should be done randomly. So that will be the necessary condition for that. Okay, so computers that are donated, computers are donated independently. So that should be, there should be no biasness in that. Okay, so computers are donated independently. You can write this down as well, students. That will give you the mark. We can also write down that computers are donated randomly basis. Computers are donated on a random basis, or computers are donated randomly. So any one of the pointers, any one of the points you can write down and you will get that 1 mark, student. That will be the necessary condition for X to have a Poisson distribution, that it will always have to be random, should be a single, or it should be an independent event as well, or single event. Now the next part is working. Now assume that X has a Poisson distribution. So we have got X is basically the variable which we have got a Poisson distribution. We have to calculate the probability. We have to find the probability that the number of computers donated during a 4-week period, student, is more than 6 and less than 9. Okay, so the computers that are donated should be more than 6 students and less than 9. So if I write it down, it means that we have to find the probability, students, which is more than 6. So we have to get the probability, sir, which will be more than 6, and it should be less than 9. Okay, which means that we have to find the probability, sir, for x is equals to 7. More than 6 means 7, and we have to find the probability of x is equals to 8 as well, and then we are going to add them. Less than 9 means more than 6 means 7 and 8, and less than 9 also means 7 and 8. So the two numbers that will come in between. Everyone should know, students, that what is the formula to apply for the Poisson mean distribution. But first important thing is we have to change the mean as well, okay? Because we have got the mean for the Poisson mean is 2.4 computers per week. So we can say that X follows the Poisson distribution. That is basically 2.4 computers per week. So if you have got for 1 week, the mean is 2.4. So you have to convert the mean, sir, that for 4 weeks, it will be multiply by 2.4 times of 4. It will be, we have got a 4-week period. That will be, sir, 9.6 for the 4 weeks. Okay, 9.6 is the mean for the 4 weeks. Hope everyone got it. That the mean will be, sir, 9.6. That will be the answer for the mean will be 9.6 students for the 4 week. That is what we are going to have. Hope everyone got it. 1 mark must be for getting the mean. I'll just write down another explanation of that. This is the Poisson mean is 2.4 for 1 week. And then if you multiply it with 4, that will be for the 4 weeks, the mean will be coming, sir, 9.6. And then just have to get the probability, students, for the 7, that the number of computers donated are more than 6. So there are 7 computers donated, and there can be 8 computers donated as well. We can have, sir, 7 computers donated or the 8 computers donated. So we'll add the probabilities of these two. So that is going to be, sir, we just have to get E minus the lambda. Everyone should know the formula, R factorial divided by the R factorial lambda. So that is going to be in order to get the probability, that should be simple. So E minus 9.6 multiply by 9.6 divided by the 7 factorial, and plus this one will be, the formula should be correctly applied, students. 9.6 to the 9.6, this will be power of 7 as well, and 9.6 to the power of 8 divided by the 8 factorial. That will be the case as well. Okay, just remember the normal Poisson distribution formula. Whatever this comes out, that will be your answer for question number part B. That is, this will be adding up of the probabilities, because the basic formula is the probability of x is equals to R will be E minus the mean times of mean power of R divided by the R factorial. So we just got the E power minus mean as common. So E power, the Poisson mean. Let's take help of the calculator, students. It will be, sir, E power of negative 9.6 multiplied by 9.6 to the power of 7 divided by 7 factorial plus 9.6 to the power of 8 divided by 8 factorial, and we have got the answer. That will be coming as 0.222. That will be giving us all 3 marks. Okay, make sure this chapter or the whole paper needs to be done to 3 significant figures, so unless otherwise stated. So we will always be giving answers when it is not stated to 3 significant figures, students. Okay, always have to give answer, students, to 3 significant figures, and that will be the case here. We have got, sir, 0.222. That will be the case. How does the marking scheme split works? 1 mark for getting 0.222, the answer. 1 mark for getting the mean as Poisson mean as 9.6, students. and 1 mark for the working that you have to find out the probability of 7 and 8. Just add them and get the answer for that. Okay. No need to show the formula. Just make sure remember the formula for the Poisson calculation. Then we have got the this 3 marks as well. The next portion we have got, students, is basically we need to get the 4 marks. Okay. The next 4 marks that we are going to get is basically part C. You have to do a suitable approximation distribution. You have to use a suitable approximating distribution to calculate the probability that more than 50 computers are donated during our 20-week period. So that is going to be, we are now going to apply, students, a normal distribution because the conditions are matching, and then it's a high value, right? So we have to use, it's a huge, that the value of computers are high, 50 computers we are looking at, and the number of week periods have gone up as well. 20-week period now we are looking at. So how do you go about it? That is going to be, sir, in simple approach. We tell that examiner, the first thing will be that the lambda was 2.4 for per week, right? So if we have to do the lambda now for 20 weeks now, so lambda for 20 weeks will be 2.4 times of 20. The lambda, 1 mark for the lambda will be there. That will be the new Poisson mean. Whatever the new Poisson mean is coming, that is, sir, 48. Okay. So we can say the concept of the conversion, the concept of the approximating distribution is the concept of the approximating distribution is that the x variable will convert to the normal distribution and we will have the mean and variance as the same. So let's call it that this would have been the point, the mean is same. So the variance will also be the same as well. The mean and variance are same for the Poisson distribution, students. Okay. The mean and the variance are same for the Poisson distribution. So that is going to be the normal distribution will follow. So let's say that X will now follow a normal distribution. We have done the approximation here. X will follow a normal distribution, which is 48 as the mean and 48 as the variance. Always remember, students, the Poisson distribution is basically a discrete variable and normal distribution is for the continuous. So we will have to do, the next step will be we have to apply the continuity correction will be coming in. That is the next important point. A lot of students must have made the mistake for part C, and that is why this paper threshold is high, that a lot of students would have forgot about the continuity correction. So continuity correction will play a very important role, and your concept of the statistics one, which is for the normal distribution, all learning of the statistics one normal distribution will also play a very important role. That is what we are looking at when we talk about continuity correction. So we need to find out, this should be the probability of more than 20 computers we are looking at. So this will become now, sir, because of continuity correction, since x is greater than that. So this will convert to probability of x is greater than 20.5. We'll add 0.5 in it because of the sorry, we have got 50 computers. Probability of x is greater than 50 computers. So that will be, sir, 50.5, that we need to, I just by mistake wrote down 20. We have to find the probability, follow again here, the probability of more than 50 computers. Since we have to find the probability of more than 50 computers, the continuity correction will come in and it will add 0.5 in it. So the probability will be find out for more than 50.5. So here we go. As always, I made the diagram. Diagram helps me. I've always taught S1 with the diagram approach. I'll draw the normal distribution thing diagram as well. I have got the mean, sir. The mean is 48. So 50 will be on the right hand side, will be ahead of it. 50 will be somewhat here, sir. So let's call 50.5 here, sir. And here we go. We need to get the probability of more than 50.5. So that should be the answer coming up. We have to get the probability that it will be more than 50.5. That is what we need to understand, the basics of the probability that it will be more than 50. Sorry, just a glitch. We have to find the probability of more than 50.5. So that is going to be, we have to find the Z value first. It will be, sir, X, the testing value minus the mean, X minus the mean divided by the standard deviation. Okay, X minus the mean divided by, sir, standard deviation, which is 48. So the Z value will be coming it because 48 is the variance, standard deviation will be square root of it. Use of a calculator, 50.5 minus 48 divided by square root of 48. I got students 0.361. Again, three significant figures will help. So you have to get the probability of Z is greater than 0.361, which everyone knows the normal distribution table can never give us greater than 0. The normal distribution tables can never give 0.3 greater than 0.361. So it is going to be the opposite of that, sir. 1 minus the probability of Z is less than 0.361, and that is going to be, students, that 1 minus, let's just try to get it. Go on the normal distribution table, and we have got, sir, the Z value 0.36 and add 1 in it. So it will be 0.64 0.6406 plus the 4 in that. So that should be 0.6406 plus 0.004. We have got, sir, 0.641. The probability of the less than is coming 1 minus 0.641, and that will be the final answer coming. 1 minus 0.641 is basically, sir, 0.359 as the answer. This will give us all 4 marks to be achieved, students. This will help us get all the 4 marks. Hope everyone got it. This is question number 1 done of the October-November 25 for paper 6 variant 2, which is completely on the Poisson distribution chapter. How does the marking works for this one, sir? 1 mark for getting the final answer, definitely, which is 0.359. According to me, 1 mark for getting the Z value as well, 1 mark for doing continuity correction as well, and 1 mark for getting the Poisson, the new mean as well, the normal distribution application from converting Poisson, like moving from approximating Poisson distribution to the Poisson distribution to normal distribution. We are approximating that. So 1 mark for that, 1 mark for continuity correction. 1 mark is basically for getting the Z value and finding out the probability, which will result in the final answer. That will be all 4 marks. So first 8 marks are achieved out of the 50 marks of this paper. Okay, 8 marks are achieved in this first question. The next question number 2 is worth 6 marks, as everyone can see, and it is based on the chapter number 2 of the book, or chapter number 2 of the syllabus, which is, everyone knows, linear combinations of the random variables. So this one is one of the easier side questions according to me. If the student knows the concept, so this will be never difficult to solve. If the student knows the concept, it's never a difficult question to solve. So what we have got is basically the random variable x has a norm. The random variable x have got, sir, the normal distribution with mean and standard deviation 3. So let's write it down. That's where we have got x follows a normal distribution, which is the mean is 10 and standard deviation is 3. So variance will be 9. Okay, we can write down variance will be 9, or we can also write down in this way as well. The mean is 10 and the variance is going to come as 9, okay, for the normal distribution. And then you have got a Poisson distribution. The y follows a basically, sir, a Poisson distribution. So we can say that, sir, y follows a Poisson distribution, which is with the mean 4. So we can say the mean is going to be 4. So the variance of this is also going to be 4, sir, okay. If the mean is 4, so the variance is also 4. Hope everyone got the point that the variance will also be 4 of this one, students. the Poisson distribution have the same mean and the same variance. That is the concept. Poisson distribution always have the same mean and the same variance, students. So that is very important to understand. The next thing is what we have to find is basically the standard deviation of x plus y. So we have got the variable, sir, which is x plus y, and we have to basically get the standard deviation. So the first concept, standard deviation cannot directly be found. We have to first find the variance of it. So that is going to be, sir, we just do variance of x plus the variance of y. That will be, let's call them a variable. So that will be the variance of the a variable, if you want to call that. Just have to add the variance of x with the variance of y. So we have got, sir, the variance of x will be 9. Okay, just we have written it down there. Variance of x plus the variance of y. So that is going to be, sir, we have got variance of x is 9 and variance of y is 4. So that will be 9 plus 4. That will be coming as 13. So that is going to be the whole total variance of the variable a. You can say, students, the total variance of the variable a, x plus y, 9 plus 4, 13. And then since we have to get the standard deviation, which will be of the a variable, that we'll call it square root of 13. And again, you can give it to three significant figures, or like answer in that form, or three significant figures. This time the answer will be coming 3.61. That will be worth 3 marks. So how do you get these 3 marks as well? Same application, students. 1 mark for the answer, or you can just write down that the standard deviation, better to write down. So the standard deviation word, the standard deviation will be coming of, with 13 is the variance. So square root of 13 will be standard deviation of x and y will be this thing. So 1 mark we have got for 3.61. The final answer, students, 1 mark will be for finding out the variance. What is the variance of x and what is the variance of y? If you understand that, that will be the all marks available for that approach. Then the next part is students part B. If you have any questions, any doubts, please put it in the comment section and I'll be able to help you out and guide you with whatever problems and queries if anyone is facing. So we have got to find out the standard deviation. Again, part B is different. So you have to find out the standard deviation now of 5x minus y. So very important to understand, it's a very important conceptual understanding that variance is never subtracted. Okay, again, standard deviation cannot be found directly. Variance is never subtracted because of the square thing. So that is going to be, I'll have to get the variance is never subtracted. So I'll tell the examiner that, let's say 5x minus y is called b. Okay, so if I have to get the variance of b, just imagining, okay, just making things convenient for the students. Let's say 5x minus y is equals to b. So the variance of b will be, you have to square. Anything that is multiplied will always be square. So it will be 5 square multiply by the variance of x. And then you add in it the variance of the y. Okay. So you just have to do that. Whatever 5 is, just square the 5. Whatever the multiple is, just multiply 5 with the square. So we got 5 square multiplied with the variance of x and then add variance of y in it. So that will be the case here that we will be adding that. So this will be 25 times of the variance of x. That will be the variance of x is basically, sir, 3 squared 9. So 25 times of 9, sir, and then plus the variance of y. The variance of y was 4, sir. So 25 nines are, and then adding plus 4 in it. 25 nines are plus 4. So we got that, sir, 229. That is the variance. And if you have to get the standard deviation SD of 5x minus y, that should be, sir, square root of 229. Okay, we have to do, sir, square root of 229 square root, and that is going to come, sir, again three significant figures. So three significant figures, so that will be, sir, 15.1 as the answer. That will be another 3 marks added to the total. So total now paper solved is worth 14 marks. 8 plus 6 will be 14 marks. So we have got the variance, we have got the standard deviation of 5x minus y, and we also have got part A standard deviation of sir x plus y. Okay. So remember, subtraction is never done. Subtraction will convert into addition. When we subtraction, minus will convert into addition when we are finding out the variances. And we need to understand that it will be the variance of x and the variance of y are available. That will be eventually getting us all 3 marks. So 1 mark for getting the final answer, students. 15.1, 1 mark for basically getting this 229, like by doing this approach. That is, we have 25 multiplied by 9, and you can say 25 times of 9 plus 4, doing that and just solving it. Like 1 mark must be for the application perspective, that this will be worth 2 marks, like getting 229 or getting the 5 square times of variance of x, multiplying these things will be eventually giving you a lot of marks, 2 marks for this and 1 mark for the final answer. You can in simple words, in summary, 1 mark for answer and 2 marks for whatever working you are showing and telling the examiner that your concepts are strong. So that is question number 2 done as well, students. Okay. Hope everyone got this and understood and is cleared as well. Moving on to question number 3. Question number 2 is done as well. Question number 3 is on, sir, sampling and estimation. And the sampling and estimation, since I've written already, it's about the confidence interval and central limit theorem, as I can read it, some points from here. So let's try to work this out. This is also worth 8 marks of question. Okay, so we have got 3 plus 1, 4, and 4 plus 4, 8. So question number 1 and 3 are 8 marks question. What we have got is basically the times in minutes taken by the students to complete a test have mean and standard deviation. So we have been given the time in minutes that are taken by the students to complete a test have mean and standard deviation. And then you have got the random sample of 100 students are noted and are used to calculate a 95% confidence interval for the mean. So we have to basically, the confidence interval was calculated at 95% students, and we have to basically understand that given that the end points of the, so we have got the limits, like we have got the we have got the end points, which is the limits confidence interval, that is 31.02 and 33.98, correct to 4 significant figures. These are basically correct to, sir, 4 significant figures. You have to calculate the value of the standard deviation. You have to get the value of standard deviation, students. So what can be done? This can be find out using two formulas. We have two methods of solving part A to get all 3 marks, students. And that is basically, we can apply, students, the width formula and also the confidence interval formula as well. You can find it using the width formula or the confidence interval formula as well. Students need to understand from the perspective here that the first thing should be at 95% confidence interval. Make sure first write this down at 95% confidence interval. What is the Z value? That should be 100% there. That at 95% confidence interval, sir, this should be clear understanding that the Z value is basically 1.96. Okay. You can find that as well. If 95% is the confidence interval, you have got 2.5% and 2.5% symmetric on left hand side, and the right hand side 2.5%, 2.5%. So you can just get the 0.975 probability from the table, like from the critical values from the table, that if you have 0.975, if you have 0.975 as the probability, it means that the Z value will be 1.96. If it is, the probability is 0.975, the Z value is 1.96. So that should be clear. And that must be, that's not a learning thing, that must be remembered. If you have practiced as much topicals, you should know at this stage, everyone should know when you're solving this question, that everyone should be knowing about the confidence interval. So confidence interval of 95%, the Z value will be 1.96. So if I apply with the width formula is basically, how do you get the width? The width will be basically, sir, the difference of them. The width will be 33.98 minus 31.02. So I'm applying the width formula. That will be, sir, 33.98 minus 31.02. That is coming, sir, 2.96. And then just apply the width formula, sir. That 2.96 is the width. Will be 2 multiplied by standard deviation. It should be 2.96 is equals to 2 multiplied by the z value, and that should be multiplied with standard deviation divided by square root of the n, number of observations, the square root of, this is the formula, right? The width is equals to 2 multiplied by the z value times of standard deviation. So just solve this. It should be coming, sir, 2.96 divided by 2 and is equals to z value, which is 1.96 standard deviation divided by, sir, the square root of the 100. We have got 100 sample, right? The sample observations are 100 students. So that will be, just solve it and you will be getting the standard deviation. Just do it in the calculator, not a problem. No need to show much working. Just do it directly. 2.96 divided by 2, multiply by 10 and divided by 1.96. So I got 7.55. The standard deviation is coming to three significant figures as, sir, 7.55. Okay, using the width formula. I have got it using the width formula, students. The standard deviation is coming 7.55 to three significant figures, and just have to apply the formula for the width. Width formula is basically upper limit minus the lower limit, or you can say the boundaries, the confidence interval boundaries. That is, the first value is 33 point, the higher value is 33.98 and the lower value is 31.02. So just the boundaries between them, just get the difference. So 1 mark must be for getting the standard deviation, 1 mark for the getting the width, or whatever way you are finding, with 1 mark for that, and 1 mark for the formula application, which one you are doing to do, which formula you are using, that will be the mark for that one. Okay, I'll just write it down here, and if anyone wants to do it with a different approach as well, they can use that. So there is another method as well, which I would recommend. Do it in the comment section and let me know, like do it on your own and write it down and see if your answer is matching with 7.55. You should be doing the other method as a practice and see if the answer is matching, which is, we can basically do it with the with the formula that we can say, we can find out the mean, sir, the mean. So you can get the mean, sir. The mean will be the midpoint of these two, which will be 31.02 plus 33.98 divided by the 2. So you can just get the mean, students, 31.02 and divided by, just get the midpoint of them, 31.02 plus 33.98 divided by 2. Get the midpoint, sir. That will be the sample mean. Okay, that will be the mean. And use the mean formula. That is coming, sir, 32.5 with the help of calculator. Get the mean formula and apply the boundary. Let's say you apply 31.02, or you can apply 30 to 33.98 as well. Apply any value. Okay, take any value, 33.98 or 31.02. I'll write it down somewhere. Let's say if we have space available. So I'll write down towards the last page. Apply this formula. Let's say that 33 point, the value, the upper boundary, like the upper limit, 33.98 will be equals to the sample, the mean plus the z value times of standard deviation and times of divided by the square root of n. Okay, so just apply this formula as well, that you can take the sum mean, which is mean, we have got the midpoint of the two numbers, the midpoint of the boundaries, and the z value 1.96 and square root of 100 times of standard deviation. Just use this formula also. You will be able to get the answer, the same answer as students. The same answer you will be able to get, which is, students, 7.55 as the standard deviation. Okay, the next thing we have got is basically, we have part B. I would recommend everyone to have a look at part B and C as well. Those are very important parts, and I think most of the students, it must be in the examiner report as well, that students were able to get part A, but part B and C, they might have lost marks as well. how to get this done. Okay. So hope everyone got this and is following as well how to have a look at this question as well. So they're asking, explain why it is valid to use the central limit theorem in this case. So what we are saying is basically why are we using the central limit theorem in this case? The calculation of the confidence interval requires the use of central limit theorem. So they are saying that we have to use central limit theorem. Why we are using it? You just have to give the answer, students. The sample size is large. As you can see that n is equals to 100. So it means that the sample size is large, and that is why the part B answer will be this one. Because the sample size is large, we have to use the central limit theorem, as it will be going to the normal approximation thing as well. Okay. Make sure, be careful. Sometimes if you write down some other things, that it might not be awarded the mark. Okay. Sometimes you are not awarded the mark as well. So be very careful about it. If the n should be, for central limit theorem to be applied, n should be greater than 30. For central limit theorem to be applied, the n should be greater than 30. So we are applying that as well. The sample size is large as well. Then part C is worth 4 marks as well. It says that a researcher calculates a number R of 95% confidence interval for the mean. So we have got an interval, confidence interval for 95% of the R. So we have to basically find the what can be the largest value of R in which it can contain R, the 95% limit. The 95% confidence interval will be looking like this, students. Have a look. The 95% confidence interval is basically this thing. And you have to basically calculate the value of the R, the largest possible value of R that can happen for the mean if the R contains the true value of the mean. If the R will contain the true value of the mean, which means that we just have to form an equation, the R, and find the largest value of R, because R confidence interval is going to contain the true value of the mean, which means it will have the mean value. The probability is greater than 0.5. So what I can say is basically greater than 0.5 means the probability is greater than 0.5. That's what we are going to say, that it will be probability is greater than 0.5. And on the right, because we have to find, should be greater than the inequality of greater than 0.5, and then it will be the 95% confidence interval means the probability of success, the probability that we need will be 0.95 as well. The probability that we need will be 0, that the value will be 0.95 to the power of R. That should be the case here, students. It will be, sir, 0.95 to the power of R. Why to the power of R? Because that is the true value of the mean. Because it contains the true value of means, it will be 0.95 to the power of R. Then just have to solve. So apply, since it's in the power form, we have to apply ln on both sides. So it will be, sir, ln 0.95 to the power of R is greater than ln 0.5. Power becomes the coefficient. Everyone knows that. So this will be, sir, R ln 0.95. It will be, sir, we will get R ln 0.95 is greater than greater than ln 0.5. Now you solve this. So what students need to understand, follow carefully. Very important point here. Once you are solving this, first do it separate values. Ln 0.5, students, will be giving you a negative value. Follow important, very careful. Ln 0.5 will be giving us a negative value, separate if you do separate. And if I do this one as well, ln 0.95, so the ln 0.95 is also giving us the negative value. Since both of them will be giving a negative value, and you can see that the negative value, remember the IGCSE concepts of the inequalities. Remember the IGCSE, just give me a minute. Remember, students, the concept of the inequalities from the IGCSE level, or the uh, other papers. Important thing of the inequalities, when you have a negative being multiplied with the R, it means basically the inequality sign will change. It will be R will be less than, because the negative sign will cancel out. Ln 0.5 will be divided by ln 0.95. ln 0.5, that will be 0.95. That will be the case. And it will be r is less than whatever the value is coming, students. ln 0.5 divided by ln 0.95, and that will be the case coming in as 13.51 something. So we can say that the largest possible value of r will be 13. Okay, so you can say the largest possible value of r will be, sir, 13. That will contain the true population of mean, that will contain the true value of the mean if the probability is greater than 0.5. So that is going to be, as we can see, it should be, sir, 1 mark for the value of r as 13 as the answer, 1 mark for making the equation, and the remaining 2 marks will be solving for the law ln thing. Like 1 mark can be for putting the ln thing as well. 1 mark can be for putting the ln thing as well. So let me repeat, 1 mark can be for putting the ln thing as well, and 1 mark can be for the solving of it as well, and that will be giving us, students, all of the question number 3, statistics 29709 marks, which will be for the sampling and estimation question. So hope everyone got it. Another 8 marks solved, which makes it almost 8 plus 8, 16. 16 plus 6 will be 22, almost 22 marks we have achieved till question number 3. So moving on, students, to question number 4 now. Question number 3, we have done sampling and estimation. The first question number 4, the hypothesis testing comes in, which everyone needs to reinforce. It's the most important learning for university level as well. And hypothesis testing, it's one of the difficult chapters that students find in all of the S2 Cambridge A level maths. So this hypothesis testing is, let's read, out of the 6 questions, we are on question number 4. And this one, the first part is worth 6 marks. And then we have got part B, another 7 marks question we have got as question number 4. So what does it say is basically an inspector believes that 18% of the cups are made at a certain factory contain flaws. So an inspector believes that the 18% of the cups that are made at a certain factory, they contain flaws. The factory owner claims that the true percentage is less than 18%. So we have got some null and alternative hypothesis. I can clearly see, students. The inspector examines a random sample of 40 cups. So we have got the sample, the n value will be 40, sir, and they finds out that 3 of them will contain flaws. So starting off, stating with a necessary assumption. You have to mention an assumption, student. So the assumption will be that, let's write down the assumption. The assumption should be that assume that the flaws in the cups are independent, the probability will be the same of every cup having the same probability of the flaw. So assume that we can say assume the flaws in the cups are independent. Assume the flaws in the cups are independent, so they are not dependent, they are independent, the flaws of the cups. Or we can say that can be, you can write down this as well, students. The flaws in the cups are independent. Or you can also mention, you can write down that it will be the probability is the same, the probability is the same, the probability of containing the flaw, the probability of the flaw in a cup is the same, in all cups are same. Okay, so the probability of flaws in a cup, in all the cups are the same. So you can write down any one of them, and you will get the first mark, student, by for writing down the assumption. Then you have to use a binomial distribution, which means that this is part 1 of the learning. Part 1 of the learning told us that this is hypothesis testing for discrete variables. Okay, this is, sir, hypothesis testing for the discrete variables. That is what we are looking at, that this is, sir, hypothesis testing for discrete variables. We are looking at the binomial distribution, sir, to test the factory owner's claim at the 5% significance level. So we have got, sir, the 5% significance level. That is what we have got. Okay, we are looking at the 5% significance level learning here. So let's get started. We will say that we have got the null hypothesis that the probability is 0.18 for containing the flaws. Okay. The cups will have flaws. Okay. The null hypothesis, starting off with null hypothesis that the probability the cups contains flaws is 0.18, and the alternative hypothesis will be, sir, that the probability that the cup will contain the flaw is less than 0.18. The probability, because this the examiner says that the inspector believes that the true percentage is less than 18%. The inspector believes that the true percentage is less than 18%. So we got probability is less than 0.18 is the alternative hypothesis. The null hypothesis is the probability is 0.18. Then the test value, we'll look at the test value, sir. The test value is basically going to be probability should be less than equals to 3. That probability of x is less than equals to 3 because they find out that it will be containing flaws, that will be 3 of them. The test value or the test statistic value is basically that they're finding out that if it's less than the 3 of them will contain flaws. So we'll have to do this, and everyone should know that we are going to reject the significance level is basically how much we have to significance 5% is the significance level, which means we have got, sir, 0 point significance level is basically, sir, the 5%, and it is going to be rejecting of H naught, sir. You are going to reject not H naught if the probability is less than 0.05. If the probability will be less than 0.05, we are going to reject H naught. That is basically the significance or the critical region. So let's find out, students. We need to understand, we need to get the probability of x is less than equals to 3. That is basically the test value, which means we have to find basic binomial distribution coming in from the S1, no, S1, the statistics 1 of paper 5. You have to get the probability of 0, sir, 1, 2, and 3. Remember the binomial distribution approach, and that is why this paper is difficult, because a lot of concepts are coming in from S1, and a lot of every question have some difficulty level that is usually not seen in other papers and other variants. So here we go. It is going to be, let's start, sir. Let's get the values. Probability of x is equals to 0 will be, we have got the sample 40, and 40 is the sample. So, sir, 40 C0 into the probability of success is the probability of containing the flaw is 0.18. So, probability of the failure will be 0.82 to the power of 40 multiplied by 0.18 to the power of 0. That's how it will be. Similarly, going on with all of them, probability of x is equals to 1. That will be, sir, 40 C1 times of the probability of failure, that will be power of 39, and 0.18 to the power of 1. Then probability of x is equals to 2. That will be, sir, 40 C2 into, make sure you show that to the examiner, 38, and then times of probability of success. The probability of success is what here? I repeat the point, students. The probability of success is basically the cup will be containing the flaw, which is 0.18. And the probability of failure is the cup will not be containing the flaws, that will be 0.82. Okay, so that will be the case here. So all of them we have to find 0, 1, 2, and 3. So that will be the answer. All of them together, 40 C3. Just add all of these probabilities, sir, and that will be the answer coming. That will be the probability coming, and then we have to check whether it is accepting H naught. We have to give the answer, students, whether we are going to accept H naught or not. So we got 0.82 to the power of 40. Then it should be like, so it will be 40 C1 times of 0.82 to the power of 40. So when we do all of them, when we just find out with the help of calculator and add all of them, the answer is coming, sir, 0.0542. The answer, the probability of adding all of them, students, the probability of x is less than equals to 3 is coming, sir, 0.0542, which everyone needs to understand is above the critical region. The critical region or the critical region, also called the rejection region, will be less than 0.05. As everyone, sometimes students better understand with the diagram. So let me also help you with the diagram understanding of binomial. It means basically if I draw the shapes 0, 1, 2, all of this 3. So this lies in the critical region, and then like this all 0, 1, 2, and 3. This will lie in the critical region 0, 1, 2, and 3. So we can tell the examiner that if it was 0, 1, 2, and 3. So the less than 3, it will be, this would have been, if it was less than 0.05, it would have been, it would have been the critical region, rejection region. If the probability would have come less than 0.05, we would have rejected H naught. So we can say that this, in this case, we have to accept H naught, students. We will have to, sir, accept H naught because of the fact that the probability, which is 0.0542, coming from the perspective of the test value, that is x is less than equals to 3, is outside the critical region. 0.0542 means, students, it is outside the rejection region, it is outside the critical region. So therefore we have to accept H naught, that is the probability of containing of law is 0.18, and the factory owner claim is insufficient evidence. Except H naught, there is not sufficient evidence. There is insufficient evidence to accept the factory owner's claim. Okay, there is not sufficient, there is insufficient evidence, or there is not sufficient evidence. There is insufficient evidence to accept the factory owner's claim, to accept the factory owner's claim. So that can be the answer, that we will be accepting H naught and rejecting the alternative hypothesis. The factory owner's claim is wrong. The factory owner's claim is completely wrong. It is not correct. The percentage of the probability is not less than 0.18. The probability is not less than 0.18. There is insufficient evidence to accept the factory owner's claim. Okay. So how do we get the 6 marks? 1 mark is already achieved by assuming, sir, 1 mark will be coming in from the null and the alternative hypothesis, sir. Then the other marks are going to come, students, getting the probability 0.0542 is greater than that. Finding out all the probabilities, that is also 1 mark. And then accepting H naught and writing down accepting or rejecting H naught, that's 1 mark. And then providing the concluding statement, providing a supportive statement. You have to provide a supportive statement as well, students. That will be very important as well. So that's how we get 6 marks. And then the 1 mark will be explain why it would not be appropriate to use the Poisson approximation to the binomial distribution. So just have to apply the what we call them as the restrictions. So we need to understand that in this case, what are the restrictions? Why we should not be applying the Poisson approximation to the binomial? We need to tell the examiner that NP should be less. We have to convert that, n should be multiplied with p. So we have got, sir, 40 will be multiplying with 0.18, and that will be 40 to multiplied with 0.18, that's coming 7.2, and 7.2 is basically greater than 5. The NP, in order to apply that, NP should be less than, in this case, it should be less than, NP should be greater than, less than 5. So that is not matching that. So NP will be greater than 5. That will be 7.2 coming. Okay. Then you can write down this restriction as well. Okay, sir, why we are not applying Poisson? Please understand why it is not appropriate to apply Poisson. It is because in the Poisson approximation to binomial, the NP should be less than 5, and that is not happening here. Here the NP is greater than 5. That is one reason you can give, or the other reason you can give, that when you have to do the approximation, N should be greater than 50. In this case, N is 40. So that is why it is not appropriate. Okay. n should be greater than 50, but in this case, n is equals to 40. So that's the other thing that we can't do. And the probability should also be very small. In this case, the probability is 18%, so the probability is high. That's why this will be giving us the marks as well, students. Hope everyone got this. We have got basically that NP will be, N is, this will be the answers that we have got for part B. Hope everyone got it. We have got another 7 marks question, which makes the total to 29 marks. Question number 4 was on hypothesis testing that we have done, and we have got the correct marks for that. Just write down any one of them that n should be greater than 50 for Poisson approximation, which is not happening. Our random sample is only 40 cups. So that's why we don't take that approximation. Or you can say that NP should have been less than 5, but since it is greater than 5, so we don't take that as well. The next we have got is CRV, which is basically continuous random. So if we talk about the CRV, the continuous random variable chapter, sir, this is going to be, we have got CRV, a full-fledged question on CRV, which is worth 5, 6, 7, 8, 9. Almost 9 marks question is coming on the CRV, which currently we're on 29 marks. If we achieve that, that will make it a high-end question as well. So we have got basically a random variable X has the probability density function given. Everyone knows that the function is valid. The continuous random variable function is valid for 0 till 2, where 0 and 2 are included. The function is there. Otherwise, 0. Otherwise, the probability will be 0. We have to show that. This is one of the straightforward question, an easy question, and the students must have got all full marks. It is about basic integration that you have to do. So I'll start solving and do it for the students. So we just take k outside, put the limits are 0 till 2, and you have got 2x squared minus x cubed as the function here, and just do the integration of it. The total probability always is 1. The total probability for the CRV functions, the continuous random variable function, is always 1. We start from 0 to 2k and just have to integrate. So how make sure show the steps of the integration. 2x cubed divided by 3, add 1 in the power, divided by the divided by that power, add 1 in the power, divided by that power. That will be it. I think so, right? And this is the integration coming. Just put the limits for 0 till 2 is equals to 1. And then we multiply that with the k as well later on. So just put the limits now, sir. That will be 2 2s are 2 power cube is 8, 8 2s are 16, 16 over 3 minus 2 power of 4. Let's take help with the calculator. 2 power 4 is also 16, 16 over 4. And when we do 0, so everything will become 0, sir. So that is what we have got. Everything turns out to be 0 when we put 0. So that is what will be the case. Just have to make k that thing. K is, this will be keeping everything the same. I've taken k as the common outside. Solving this, substituted the 2. When I substitute 2 in the x values, I have got 16 over 3 minus 16 over 4. When I substitute 0, students, I got 0. Just simplify and solve this. So that will be 16 over 3 minus 16 over 4. That is coming, sir, 4 over 3k. And here we have got the proving of it. This will be, sir, 4 over 4k over 3 is equals to 1. Just get this 4k is cross multiply 3, and the k value will be coming 3 over 4. So 1 mark for integration, 1 mark for putting the limits 0 and 2, and 1 mark for getting the k value as correct, which will be 3 over 4. That's how all 3 marks split will be there, students. 1 mark for this, 1 mark for putting the limits, and 1 mark for the integration. That's how we have got the first 3 marks, students. Then part B says that we have to get basically the median of the x is denoted by m. Okay, so we have got, sir, the median of the x is denoted by m. So median means the half, the probability will be half. So if we have the total probability 1, the median will make it 0.5. We just have to write down the probability that the probability of x is less than the median. So always remember median is basically, just write down means it will be 0.5 the answer, no need to solve anything. The word write down means just have to give the answer. The probability of always less than median will be 0.5, sir. Just have to see the word of write down. The total probability will be half. So everyone got it? That we have got basically, sir, the 0.5 is the probability. 0.5 is the probability for less than the median. Okay, less than equals to median. 0.5 will be the probability, sir. Then the next part worth 5 marks. That's a huge part that we are discussing now, which is worth 5 marks. It is that hence find the probability between the mean and the median. EX stands for, let's write it down, students. This is, sir, EX stands for the mean, and this one will be standing for the median. Just have to get this. So what students need to understand, we have already got. Understand how will you get it? We have already got the 0 till the median. The probability of the function will be 0.5, right? The probability of the function will be 0.5 from 0 till the median. Hope everyone understands. From 0 till the median, the probability is going to be, sir, 0.5. So what we can do is basically just find out the probability of the 0 till the expected value, the mean. Just find out the probability of that. Whatever it will be, we can subtract from 0.5 and that will be the answer. I'll help you out and explain that. So first thing will be, we try to find out the mean. How do you find out the mean, students? That is very important. Okay, so let's have a look. Everyone should focus. The expected value of the mean is basically always, when you have to find the mean, it's always x will multiply, okay, with the function. So since we have got the k value now, 3 over 4, I'll take it outside, so 3 over 4, and you have to integrate. The whole function will multiply with the x, okay? The whole function will be multiplied with the x, sir. When we have to find the expected value, the mean, it's always x multiplies. So that should be the first step, is very important. You have to first multiply and then integrate. 2x squared minus x cubed times of the dx, and we are going to integrate from, we are trying to find out the mean, which is basically the expected. We are just basically trying to get the mean value as well by putting the limits 0 till 2. Okay, we'll put the limits will be, sir, 0 till 2, the same approach, limits will be same. Let's get the integration done and find the answers. Will be, sir, 3 over 4 times of, let's first multiply 0 till 2. This will be, sir, 2x cubed minus x power 4 times of dx. Okay. Now we integrate that, sir. So integration will be, sir, 2x to the power of 4 divided by 4, x to the power of 5 divided by 5, plus add 1 in the power and then subtract, divide by that power. Add 1 in the power and then divide by that power, keeping everything same. This will be what we are looking at to get the probability. We are finding out the mean value. We are trying to find out the mean value, that is basically the expected value that we are trying to find out, students. It is going to be, again, when we substitute 0, it doesn't matter, just 2, putting the 2 will help us. So that is going to be, sir, whatever the value comes, 2 power 4 times of 2, that should be 32 over 4 minus 2 power 32 over 5 times of 3 over 4. That will be the expected value, students. That is what we are going to get. So the expected value will come out. Just solve this. 3 over 4 times of 32 over 4 minus 32 over 5. That is going to be, sir, 6 over 5, which is basically 1.2. So we have got the mean or the expected value, students. The mean or the expected value is basically 1.2. Once you have got this, as I said, you can find out the probability of between 0 to 1.2. So let's do that. Just find out the probability of 0 till 1.2. We do that. Okay, we try to find out, this is the expected value. Try to get the probability of 0 till 1.2. We already have the basic function, the normal equation. You substitute in that, you have already got the integration of that. This will be, sir, 2 over 3x cubed. Just already this is available. Just put in there and get the probability. Now we are finding the probability, 3 over 4 times of Just copy pasting the question from part A, 2 over 3 x cubed and minus x power 4 divided by 4, right? And the limits will be, sir, the limits, I'll put back the limits. So that is going to be 0 till 1.2 that we are looking now. So that will be the answer coming. Hope everyone got it. I have to find the probability from the mean, from the expected value mean 1.2 to the median. Since we don't know we don't have the median, what I did was I told everyone the basic important point that the 0 to median will be 0.5. The function starts from 0. Hope everyone understands. The function is starting from 0. So 0 till whatever the median value will be, from 0 till whatever the median value will be, the probability will be half 0.5, students, because total probability is 1. What I'm doing is I'm finding the expected value, which came out as 1.2. The expected value came out as 1.2. So I'll find the probability. The mean came out as 1.2. I got the probability from 0 till 1.2 here, which is going to come out now. That is going to be 2 over 3 times of 1.2 to the power of cube minus 1.2 to the power of 4 divided by 4 multiply by 3 over 4. So we got something, the answer as something 0.4752. So 0.4752 is the probability from 0 till. So now we can say, tell the examiner that if we subtract the probability for the expected value till the median value. The expected value till the median value is going to be from the median 0.5 minus 0.4752. That will be the answer, students. 0.5 minus 0.4752. That will be the answer, which will be 0.0248. Okay, so we have got 0.0248 as the answer for this one. So everyone got it and it's cleared with the understanding and the learning of this one. So we got 0.0248. Hope everyone understood that it's a tricky one. A lot of students might have got mistakes in this one as well. It's a very simple approach. I'll show it with a understanding of what is happening here with this thing. Understand, we started off with 0, sir. What everyone should understand that this is 0 and this is, imagine, the median. So I know that the 0 till the median, everyone understands that the probability is basically 0.5. This whole probability, the orange highlighted part, is 0.5 is the probability. But then what happened is basically expected value is coming somewhere here. The expected value is 1.2. So 1.2 is this value on the number line. So what I'm doing is basically I found out the probability of 0 till 1.2, the expected value. So that is coming basically, sir, 0. This is coming as 0.4752. So this is coming 0.4752 and the whole probability was 0.5. So since we need this portion only, which is, let's call it with the blue, let's call it the red highlighter part, we need expected value to the median. This will be 0.5 minus 0.4752. The answer comes as 0.0248. The last step will be that, sir, we have to get basically the marks for that. 1 mark for the final answer, sir. 1 mark for final answer. 1 mark for getting the expected value. 1 mark for getting 0.4752. And the remaining 2 marks will be for basically for getting the expected value, like the 1.2. How do you multiply 1 mark for getting the expected x value as well? Hope everyone understand. And then 1 more mark can be for subtracting the areas or some other working as well. That's how the 5 marks will be done as well. Hope everyone got it. Question number 5 was on CRV and we have got it. And now we'll solve question number 6 as well, which is again on hypothesis testing, which will be worth 12 marks as well, students. which will make it all 50 marks we have reached. Question number 5, make sure that we have reached till 38 marks, and understanding and importance should be clear for. So question number 6, students, is basically on the hypothesis testing for the normal distribution, which we can also say is the Z test. So as I said, hypothesis testing comes a lot larger portion in the A level maths 9709. And this paper is a perfect example on that, students, in which we have S29709, October, November 2025. Question number 4 was basically on the Question number 4 was on hypothesis testing for the binomial distribution, discrete. And now we have got a question number 6. It's a huge 12-mark question on basically with three parts on basically the understanding of the hypothesis testing for the normal distribution. So what we have got, students, is basically the weekly profit in dollars, which is made by a certain firm, has a normal distribution. So we have got the normal distribution variable, the weekly profit in dollars, which is made by a certain firm. We have got that. And then the examiner says, in the past, the weekly profit have the distribution 736 as the population mean or the mean, and 26 square is the variance. Following a change in the management, the mean weekly profit for the 35, so the number of samples we have got, the number of observation students are 35. Okay, the number of observations are 35 for randomly chosen week is $725. Again, you have to state a necessary assumption. Marking scheme matters, students. You have to test at now the 2% significance level. Question number 4 was on 5% significance level. Now we'll be testing whether the mean weekly profit has decreased or not. So again, the first thing is always about the assumption. So we assume that what will happen, sir? Assume that the standard deviation is 26. It's still 26. Or you can say that this can be the assumption, or you could have mentioned that assume that the standard deviation is unchanged. Okay, assume that the standard deviation is unchanged. Both of them will give us the first mark. Okay, students, both of that will give us the first mark. What we have got is basically the null hypothesis. The null hypothesis says that the population mean, or we have got the mean will be 36, 736, and the alternative hypothesis will say that the mean has decreased, mean is less than 736. The population The alternative hypothesis will say, students, that the population mean has decreased, which is the mean is less than 736. Null hypothesis will say that the population mean is 736. The next important thing we have got is basically we are testing at the 2% significance level. So we will reject H naught if the probability will come less than 0.02, which is the 2% significance level. That, sir, we will be rejecting H naught if the probability will come less than 0.02. Let's apply the test statistic value, which is 725 test statistic value for the normal distribution test statistic value. Part A is easy, not a difficult one. It will be, sir, getting the Z value. So Z is equals to test value 725 minus 736 divided by the sample divided by the standard deviation 26 divided by square root of the sample, sir, which is basically 35. Okay, divided by 26 divided by square root of 35, that will be coming in. So we have to basically get the Z value, sir. So the Z value, let's take the help of the calculator. 725 minus 736 divided by 26 divided by square root of 35. So I'm getting the Z value as minus 2.50, something huge value. Let's do it 246, 3 decimal places. So, sir, the Z value is coming minus 2.503. So we can just find out the value and the probability of it. So it will be chosen as 725. Let's make the diagram. A lot of students find the diagram more easy to solve. A lot of students take help from the diagram solving as well. So let's take that into account. So we have got normal distribution. So we have got the normal distribution, which is basically the mean as 736. And definitely we are looking for the basically the value, which will be 725 will be this. And we are looking for the less than probability. So 725. So you have to get the probability of the less than 725. Okay. So let's find that. That should be coming, sir. The probability of the Z is less than minus 2.503. You can't get it directly, sir. It will be 1 minus the probability of Z is less than positive 2.503. So I'll just find out from the table. We just have to find out from this table, sir. 1 minus the probability of Z is less than 2.503. That is going to be 2.50, and we have got the 3 as well, which will add nothing. So 0.9938. So 1 minus the probability, students, of 0.9938, and that will be giving us the answer. That is coming, students, 0.0062. Okay, so the answer is coming 0.0062. That is the probability for less than the test statistic value, $725. That they are saying that the randomly weekly profit is $725. So we got this. Now we can compare if this value, let's follow, students, the answer, the probability is definitely less than 0.02. So it is going to be reject H naught. The conclusion, the answer will be, sir, you have to reject the null hypothesis. There is sufficient evidence, there is enough evidence, or there is sufficient evidence that the mean weekly profit has decreased. Okay, there is sufficient evidence that the mean weekly profit has decreased. There is sufficient evidence that the mean weekly profit is decreased. We are going to reject H naught and accept the alternative, mean weekly profit has decreased. Okay, that is what we have, students. As always, I've told you always the marking way as well, how students will get the marks in the Cambridge exam. That will be 1 mark for the null and the alternative hypothesis, 1 mark for writing down the assumption, which is basically that standard deviation is unchanged or that thing. Then 1 mark for finding out the Z value, 1 mark for finding out the probability, and 1 mark for rejecting H naught, and 1 mark for the conclusion of it. 1 mark for the conclusion, 1 mark for the prob, 1 mark for getting the Z value. These all things will help you get the answer or the working all 6 marks. The first part was worth 6 marks, and 6 tick marks are there as well. Then remember from the notes and the understanding, always remember the state means just write down the answer. What is the probability of a type 1 error? The probability of a type 1. So the probability of a type 1 error is exactly the same as whatever the whatever the critical region and whatever the rejection region is. So as according to the notes as well, the type 1 error is basically whatever the significance level is, that will be, students, the type 1 error. Okay, let's read the question as well for part B. The mean weekly profit for the another random sample of 35 weeks. So the part B and C are linked with this portion. Okay. Part A was a separate portion, students, and part B and C are linked with a separate information available for that, which we have got. The mean weekly profit is basically we have got is 35 weeks is found, and a similar test is carried out at the 2% significance level, which means that the probability of a type 1 error is basically going to be 2%, which is the test significance level. So we can say 0.02 as the answer as well. Just have to state it. So part B for 1 mark will be the type 1 error probability is 0.02, which will be 2% significance level, also called as 0.02. Then we have got part C, students, which says that you have to find the probability of a type 2 error now worth 5 marks question. So a lot of working will be needed to get those 5 marks, given that the mean weekly profit is basically now in fact $718. Okay, given that the mean weekly profit is basically $718, we have to basically find the probability of a type 2 error. Okay, that is for the part C that we have to do. So first thing, your understanding of type 1 and type 2 errors should be clear. Let's quickly revise. If we are finding out the type 2 error probability, it means that it is a wrong decision, that our test leads us to accept H naught, although the null hypothesis is false. The null hypothesis is false, but we still have accepted the H naught, the null hypothesis we have accepted, and that is what is called a type 2 error. So how do we start things will be, the new mean is 718. We'll take that into account later. First, we need the test value. What will be the test statistic value now, considering we have got a different sample and we have doing it at 2% significance level. So we can say, let's call that value Y or something A value. Let's call that A. So just have to get that we have basically, we have to find out what will be the at 2%. So at 2%, the probabilities, what is the Z value? So when the probability is 0.02, so what is the Z value at that? So you can easily get it from the table as well, that if you can, it will be the same. If you have 98% probability or if you have 2% probability, it should be giving the same answer. So we have got at 0.98 or at 0.02. So let's try to find that out, that it is going to be, here we go. So we have got 2 point at 0.98. So that will be 2.05. So 0.9798, we have to just add 2 in it. So 2.054 or 2.055. Okay. So it is going to be said 2.0454 or 2.055. So with the negative value, because we are looking at the less than side. Okay. So it is going to be 0.02. Probability will be, the Z value is going to come, students, negative 2.054, or the Z value at 2% significance level, the Z value or the Z value is basically minus 2.054. So once we have got the negative 2.054, the Z value, I'll find the test value, which is A minus the, we have got the old one, which is 736 as the previous mean. We'll take help from part A. The previous mean, because we are finding the test value first for the new mean. Okay. We'll solve it once we have got the type 2 error, no? The probability of that. So A minus 736 divided by A is basically the test value that we are looking at for students, divided by 36 as standard deviation, because variance is, sorry, 26, not 36, 26. 26 is the variance standard deviation divided by the same sample that we have got at 35 weeks. Okay. The random sample is 35 weeks. We are looking at the data of, sir, 35 weeks. Okay. So this will be equated to minus 2.054. This will be equated, sir, to minus 2.054, and we'll have to find the A value. So let's just get the A value by simplifying and multiplying. So negative 2.054 will multiply with 26 divided by square root of 35, and then we add in it plus 736. So A value is coming, the test value 726.973. Okay. So 726.973 is the A value, or you can say the test value is coming for the type 2 error. The type 2 error, we'll have to get the new value now. And once we have got this, we have got the new mean available. We can use that, given that the mean weekly profit is now in fact $718. So you can apply again, find the probability of a type 2 error. So Z value will be, sir, 726.973 minus 718 divided by the same 35 random sample weeks divided by the same standard deviation. We are assuming that the standard deviation does not change. 26, and so we'll do that and we'll get the Z value. Let's do it in the calculator. 726.973 minus 718 divided by 26 divided by square root of 35. That will be coming as 2.04. Okay, so we have got 2.04173. That is what the Z value is coming. And then since we already know, we can round it off to 2 point. We have to get the probability of Z is greater than 2.0473. So that will be the probability of needing greater than Z is greater than 2.04173, because as I said, type 2 error is that when we have to when our decision is leading to accept H naught, but in fact the H naught is false. So that will be probability of type 2 error. So this time we'll find the greater than probability. The greater than probability will be coming that 1 minus the probability of, this should be 1 minus the probability of Z is less than 2.042. Let's round it off. I have rounded off the 2.04173 to 2.042, and that will be going on the table, students, and finding out what will be 2.042, right? So the Z value is 2.04 and 2, so that will be 0.9788 plus 1, so 0.9789. The 1 minus the 0.9789, and the answer will be in front of us. That will be coming as 0.0211. 2.0, let's double check. 0, we have got 0.97, 2.04. What's the Z value coming? The Z value is 2.042. So we have got 2.04. So 2.04 is this one. And then adding 2 in it. So 0.9793, just a mistake of the looking at the table. We have to look at this one, 2.04 and 2. That will be 0.9793 plus 1. Okay, 0.9793. So that will be 0.9794. This will be a little bit error, 0.9794, and 1 minus 0.9794, that will lead us to 0.0206. That will be acceptable and the correct answer to get all 5 marks. With this, we have completed the Cambridge A Level Mathematics 9709, Paper 6, Variant 2 of the Statistics to S2 level, which is how does the marking scheme works for this one. 1 mark for the final answer, which is 0.0206. 1 mark for getting the new test value because of the type 2 error, the new test value. 1 mark for getting the Z value again, the new Z value, and then 1 mark for getting the probability minus subtracting it. That will be all the marks as well. Okay, we can say that 1 mark can be for finding out this sample, the Z value way minus 2.054. And then this, all of this could be 1 mark as well, and the final mark will be definitely the third mark for getting 2.042, and the fourth mark for solving the probability, and the fifth mark for the answer. That is how it will be all of October, November 25 solved with the question number till question number 6. Make sure to revise the paper, and if any questions are there, do ask in the comment section, students. Thank you.